Hey guys, and welcome to this lesson on Year 1 differentiation. Now you're here because maybe you've just started differentiation chapter and you're quite confused, or maybe you just need a refresher. Whichever one you are, you're in the right place. So I'll see you after the intro. Now before we begin, you may have noticed this around the top, and this is just to show you the basic mechanics of differentiation. So I'm just going to quickly show you what it means to differentiate. You want to look at the power and you want to bring it to the front here, down here. So when you do the differentiation, and if you've been given y, it would be dy over dx to show that you are differentiating. And obviously if you're given f of x, then it would be f dash x. And what happens is you bring the power down. So this will now become n, and then you'll have your x, and then you'll take away 1 from the power, just like that. So on this one, it will be exactly the same thing. So you'll have n, x, n minus 1, okay? So just to recap, you bring the power to the front and you multiply with whatever's there, the coefficient, if it's there, and we'll look at this through these examples, and then you take 1 away from the power. And that's it. So let's have a look at these questions. So we want to differentiate all of these different examples. So let's go and differentiate this one. So dy over dx. We're going to bring the 3 down here. So we get 3x, and we take 1 away from the power. So there's a 3 there, and therefore we have 2. Next one, we bring the 4 down here. So when we differentiate this time, I'll use f dash x, and I'll vary them just to get you used to it. So f dash x, we bring the 4 down here. We get 20x, and we take 1 away from the power. So we get 20x cubed. Now onto this one. Now before we differentiate this, we have to standardize it for differentiation, because as you can see, we have no power that we can bring down. So we need to change the way this appears using indices. So this is equal to x to the minus 1. Now we can differentiate. So now we can do f dash x, and we can bring the power down, so we get minus 1. We don't need to write that 1, so we just write minus x, and we take 1 away from the power, which gives us minus 2. So that's differentiation. This one again, what we need to do is use our indices. So root x is power over half. So when we differentiate this now, we get dy over dx is equal to a half x, and we take away 1 from the power, which would put us minus a half. This one, we will rewrite this as 3x to the half. So when we differentiate this, so dy over dx, we bring the half down here, giving us 3 over 2x to the power of a minus a half. Now these two, as you can see, you've got several different terms in your expression, so we'll do them individually. And for the first time, we meet where we have a power of 1 on the x, and where we don't have anything, we just have a constant. So let's see what happens. So when we differentiate this, let's use a different color pen. So let's use f dash for this one. So the 6 comes down here, giving us 12x to the power of 5. Now here, what do we have? We have 3x, and x has a power of 1. So when we bring that 1 down here, it multiplies with the 3, giving us plus 3. And then x, you take away 1 from the power, giving us x to the 0. X to the 0, or anything to the 0, is 1. So it's 3 times 1. So we don't need to actually write anything. So you can think of it like that, or whenever you see 3x or 5x, it will just be that one's number. As for the constant that we have here, 5, well, we do have an x value here, which is not written. It's actually x to the power of 0. So when we take down that 0, we multiply 0 times 5, giving us 0 overall, so we have plus 0. We don't write plus 0, so we don't really need to write anything. So whenever you see a number, then that number disappears. So the differentiation of this is really applied to those two, giving us that. Let's move on to our final example before we move on to those harder expressions. So here, what ones do we need to rewrite? We need to rewrite these two. So let's do that very quickly. So that's okay to stay as it is. This one will become plus 4, and x will come up with a negative 1 over 3 power. And then this one will be 2x to the power of minus 2 plus 1. So dy over dx will be, the 2 will come down here, giving you 12x to the power of 1. As for this one, the negative will come down here, making this negative overall. And the third, 1 over 3 will multiply with the 4, giving us 4 over 3 x. And again, the power, minus 1 over 3. If you take away 1 from that, you get minus 4 over 3. Here, the minus 2 will come down here, giving you a positive, and you have 4x to the power of minus 3, and the 1, like we did up here, will just disappear. So this is the differentiation of that. Let's have a look at these last 4 examples to finish this lesson off. We've got x squared plus 3 over x. So what we want to do is break down this fraction. What we can do is do x squared over x plus 3 over x. And as you can see, that will take away 1 from there. So you're left with just x plus 3x to the minus 1. And we are now going to differentiate that. So dy over dx will be, you get what here? 1 minus 3x to the minus 2. And that is the differentiation of that. Moving over to this one, we'll rewrite this first of all as 1 over 3x to the minus 1. Sometimes people mistakenly bring the 3x right here, which is incorrect. So make sure, what I will show you actually, is you can rewrite this as 1 over 3 times 1 over x. So as you can see, this is here, and then this is right there. So when we differentiate this now, we get dy, or actually it's f of x, so f dash x. We bring the minus down here, giving us a minus x to the minus 2. This one over here, we can again break it up similarly to this one. So therefore we can have y is equal to 2 over x squared plus x cubed over x squared. And then here, we can rewrite this as, let's just do it here. So we can have y is equal to 2x to the minus 2. And then here, 3 minus 2 is just 1. So therefore, we can just have x to the power of 1. And then dy dx of this would be minus 4x to the minus 3 plus 1. Finally, the last one, maybe you want to try it. Maybe you can pause anytime you want. Remember that in any of my videos, pause anytime and try the question if I don't say it. But this one, maybe you want to pause and try it yourself. And then press play again when you're ready. All right, hopefully this is what you've done. You've broken it up the following way. So first of all, the denominator here can be fixed. So 1 plus 2x and then 3x times x to the power of a half. And what happens here? You got 1 here, you got a half here. So you do 1 plus a half, which is 3 over 2. So we can get rid of all of that and just write 3x 3 over 2. Next, we'll split this up as before. So the 1 over 3x 3 over 2 plus 2x 3x 3 over 2. Now, we can rewrite this as, this part here will be a third x minus 3 over 2. And this one will be 2 over 3. And then 1 minus 3 over 2, which is x minus a half. And we've run out of space here, so we're going to do the differentiation of this up here. There's a tricky one here, because we've got a fraction coming down and multiply with a fraction. It will give you minus, the 3 and the 3 will cancel, so you get 1 over 2, so a half x, and then you take away 1 from the power, giving you minus 1.5, 2.5, so therefore 5 over 2. Again, similarly, it will happen the same thing here, so minus, and then you got a half multiplying with that. Again, the 2 and the 2 will cancel, so you get 1/3, so minus 1 over 3x, and then you take away 1 from the power, minus 3 over 2. And that is the differentiation of that. Hope you've enjoyed this lesson. You know how to do the basics of differentiation and break down those harder expressions. In the next video, I will be looking at finding the equation of a tangent and the equation of a normal using differentiation. So see you then. Bye for now.